Okay, welcome to Math 65. This is our first lesson on graphing systems of linear equations. In the last video, we were talking about a review of graphing, and today we're going to extend that further. Systems of linear equations are basically two equations figuring out when they cross, if they cross, where they cross, and if they don't cross, that means something too. So today's lesson is about systems of linear equations. To introduce this idea, let's think about linear equations, how they behave, okay? Consider the equation 2x plus 5 equals y. What x value satisfies this equation? Graph them. Okay, so right here, how could we solve? Essentially, how could we solve for x? So to solve for x, we're going to subtract 5 from both sides. We get 2x equals 6, and we can divide both sides by 2, x equals 3. If I were to graph the solution, it's just 1 point. X equals 3, there's one solution. How do I know that this solution is correct? Oops, that's 3. That's the only solution. Here's 0, here's 6 maybe. We could check it. And that's something I always ask my students to do whenever possible. 2 times 3 plus 5, is it equal to 11? 6 plus 5 equals 11. Yes, 11 equals 11, so that means my solution is 3. And you can also use set notation. Set notation. Okay. Consider the equation x plus y equals 10. What x-y pairs satisfy this equation? So if we were to create a table of values with x and y, how many different solutions could you come up with that would be two different numbers to add to 10? Sure, 5 and 5 is a solution, which is the ordered pair 5, 5, or 1 and 9, 2 and 8, 3 and 7, 4 and 6, good. And then also the reverse of those. Is this the same pair, 6, 4? And what if there was negatives? This is all different because it's a different order, even though it's the same numbers, right? What if we continued this table x, y, and we had negative 1 and 11, negative 2 and 12? You know, you can see that we have an infinite number of points. What if I had 0? That would be 10. What if I had 10? That would be 0. So if I start to graph these points, I have, here is 4, 6. Here is 6, 4. Oops, that's not 6, 4. That's 6, 4. 8 and 2, 2 and 8. And you can see that what happens if you graph all the points is they form a line. So this is a linear equation in two variables. And how many points would you say, how many x, y values could satisfy? Yes, it would be an infinite number because you could even have fractions. You see all of these points here in between. There's an infinite number of points on the line, which is the reason why we draw arrows at the end. Okay, now if we consider the system of equations, we have two different equations. In order to graph these, I'm going to graph the first one, which is very similar to the last one here. X plus y equals 6. Here's x and y. 3, 3, 2, 4, 4, 2, 0, 6, and 6, 0. Now these 2 points are special. We talked about them in the graphing videos. Can anyone tell me what these 2 points are? Yes, they're the intercepts. This is going to be the y-intercept because x is 0, and this one is the x-intercept. So if I want to graph this, I can go 2, 4, 4, 2, 0, 6, or 6, 0. I set them backwards. And then, of course, you have negatives involved in that as well, so I draw that line. Now, since this is a system of equation, it has a second line as well. It's a little bit trickier to create a table of values here, so what I'll do instead is I will set it equal to y, so I'm going to subtract 3x from both sides. I get negative y, don't forget that negative sign, equals negative 3x plus 6. And how do I get rid of that negative in front of the y? You're right. That is a coefficient of -1. So I'm going to divide everything by -1. And I get y by itself equals negative divided by negative is a positive 3x minus 6. So to graph this, I'm going to start at my y-intercept -6. I'm going to rise 3, run 1. So I'm going to count up 1, 2, 3, rise, oops, run 1. Go up 3, over 1. There's my x-intercept since it crosses the x-axis. Go up 3, over 1. Looks like that's a point right there, right? 3 over 1, so that's 3, and that's 3. Actually, 3, 3. 3, 3 was a point on the other one as well, so that's where the lines cross. So the solution to the system is where do these lines cross? And again, I'm really big on the idea of checking. How could I check to make sure that the solution really is 3, 3? So I'll have two checks. Check number 1, I'm plugging in 3 plus 3 equals 6. Yes, 6 equals 6, because this is my solution. That's check number 1. Check number 2 is plug it in. 3 times 3 minus 3, is it equal to 6? 9 minus 3 equals 6, 6 equals 6. So this right here is my solution. My solution is this ordered pair. So only one ordered pair will satisfy the system of equations. The definition, a system of equation is two or more linear, or actually it could be just equations in two variables. Okay, the solution to the system is the point of intersection. Okay, and that's going to be an x, y ordered pair of coordinates. Okay, let's look at the next one. Okay, and I'll actually stop this one and do the next one in the next video.